And we are now rolling. So we are on Unit 11, Notes number 4, Application of Exponential and Log Equations in this fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Gu. So this is the last section of notes before the test, okay? This is, as it says, Application of Exponential and Log Equations. This is going to be about continuous growth formula, which we've already done before, and a new formula called half-life. Ooh, yes. All right, so anyways, we're going to cover this just briefly again because we've already done this before, but you're going to see it again, so we need to just make sure that we know how to do it for sure. All right, on the test, right, you're given formulas, but they don't tell you what the variables mean, so you got to make sure you know what the variables mean. So this big A, does anybody remember? What does this big A mean?
Just the base.
No. That is the final amount. It is the final amounts. So if that's the final amount, what does P mean? The principal, right, or the starting amount. Very good. Principal or starting amount. Nice. And what is R? The rate. And the rate has to be a decimal, remember? Exactly, yes. And what is T? Time. All right, good. So let's just do some quick problems right here. Example 1. If $10,000 is invested in an account paying 4% annual interest compounded continuously, how much will be in the account after 10 years? How do I know that I'm supposed to be using this formula and not some other formula? Compounded continuously. That's the key word right there. Okay, which variable are we looking for? A, that's right. So A equals P times E raised to the RT. That's the formula. We're looking for A, so everything else should be given. So what is the starting amount here then, the P? 10,000. What do we have to put in the calculator after 10,000? E. Some people literally took E out of the equation and just put 10,000 raised to the RT. So that's not right. All right, now what is the rate? 0.04. Right, because it's 4%. You got to move the decimal over twice. Leaves you with 0.04. Yeah, the time is 10 years. So remember, most of the problem, right, most of the points come from being able to set up the equation like that. Then you just have to put it in the calculator and find your answer. But when you write your answer, you got to write it the right way. So what is your answer? What would you write on your test if you were to write an answer? Dollar sign? Okay, good. What did you say? What was the answer? That seems lower than what you started with, which is not possible because this is gaining interest. Yeah, 14,918 and 2 cents. 2 cents. 0.2 is how many cents? 20 cents. You just put a 0 after that. 20 cents. I think you typed 1,000 probably. It's 10,000.
Oh, okay.
Yeah, so $14,918.20. Okay, 2 cents would be 0.02. All right, let's do another problem right here. Mark receives 5,000 whole dollarinos from his grandmother on his 18th birthday. Wow. He invests it in an account paying 5% annual interest compounded continuously. How much will be in his account when Mark is 38 years old? So this guy got $5,000. He put it in his account and didn't touch it for 20 years. Wow. Okay, so what is the starting amount here?
5,000.
So A equals 5,000 times E raised to the,
0.05.
right, because 5%.
38 years.
It is 20, that's right. Why is it 20?
38 minus 20 is 18.
38 minus 18 equals 20, yes. You said 38 minus 20 equals 18. Yeah. All right, so there's the equation. 5,000 times E raised to the 0.05 times 20. What would be your answer? Dollar sign. And 40 cents. Very good. Nice. the questions ask for the equation and the answer. Yeah, you have to write it. Unless you just don't want the points for that one, then you don't have to. But yeah, the whole challenge of this is being able to write the equation. Putting in the calculator should be the easy part. All right, so the third and final question right here is going to be the frog population on an island in 2011 is 15,000. The frog population grows continuously at 2.5%. Find the frog population in 2021. So what are we looking for? We're looking for big A. So what is my starting amount of frogs? 15,000 frogos times
2.5%.
times E.
Oh, yeah.
0.25 and then
Times 10 years.
Right, the starting amount is 15,000. The rate is 2.5%, which you said changes to 0.025. Very good.
So even if it's already a decimal, we still have to change it?
Yes, you still have to change to the actual number you could put in the calculator. And then what is the years? 10, right, because from 2011 to 2021 is 10 years. So there's the equation. Now let's get the answer.
19,360.
Very good. So notice, Aiden just stopped, it said 19,260. Why did you say that as your answer?
Because you can't have like half a frog.
Exactly. Because then it would be dead and it wouldn't be part of the population, now would it? Okay. There you go. All right, so next thing. So that was kind of a review, right? We did that before, but now here's something that could be new to you. This is half-life, all right? So if maybe you learn about this in biology, you probably learn about this in chemistry, and then if you take earth sciences, you probably learn about that as well. So half-life is a substance, it's how long it takes a substance to lose half of whatever it was. So a lot of people get confused in chemistry because it's kind of abstract. You don't actually see, your compounds or chemicals like that, especially when you're talking about radiation and things like that. But a quick way to describe this would be like this. You see this water bottle, right?
Yeah.
If I drink half this water in an hour, then the half-life of this water bottle was 1 hour. You see that? So in an hour, I drink half of it. Then the next hour, I drink half again. Then the next hour, I drink half again. That's what half-life is. All right? That's how half-life works. So, all right. About to say. All right. Anyways. But people use half-life to determine how old things are based on how much remains of a certain substance. So, like scientists will use, or paleontologists, whatever, will use the concept of half-life to tell you how old fossils are. They're like, this fossil is 2 million years old because they use the concept of half-life. All right. Anyways, so there's two formulas here. However, we're just not going to use this first one because this only applies sometimes, and the second one you can always use. The first formula is based on the second one, but really unnecessary. Okay. So, what we do need to do is define the variables, okay? So, big A, what do you think that means? It's the same thing as last time. Final amount.
So we don't use the first one.
Right, because you can always use the second one. First one you can't always use. All right, so then, what do you think A of 0 means then?
Half of
The starting amount. Because that little 0, it means at time 0. So what is the amount at time 0 before you've started timing, So that's the starting amount. Okay, then of course there's a 1/2 right there because this is half-life. Okay, there's of course going to be a half somewhere in there. Now here's the confusing part that you got to make sure of. T is the time that has elapsed. T is the time that has elapsed, or the time that has passed, okay? And H is the half-life. So those are different. They're both time values, but you got to make sure you know which one goes in which spot. Okay? So let's take a look at how we would use this formula to solve some problems. So this first example, a substance has a half-life of 20 years. Well, first of all, I know to use the half-life formula because I see the word half-life in the problem. If there are 225 kilograms of the substance now, how much will remain after 100 years? So the formula is A equals A of 0 times 1/2 T over H. So let's fill in what we do know. What is the starting amount here?
0.
The starting amount of the substance. 225. We're starting with 225. Okay, and then we multiply that by 1/2. Now we have to raise it to the time over the half-life. What is the time here? 100 years, right? Because it says remain after 100 years. Remember, t is the time elapsed. Over the half-life. What is the half-life? 20 years. They tell you the half-life is 20 years. And so there is the equation. 225 times 1 over 2 raised to the 100 over 20. Put that in the calculator and that will give you your final answer. So what is your final answer? 7.03. What are the units? kg, that's right. There's the answer. You use the caret sign to do the exponent? Yeah.
I got 225 with a
Then change it to a decimal. Press Control Enter. Yeah. You got to get the answer and then just immediately press Control Enter. All right, now really quickly, just to explain what half-life is so you can kind of understand what half-life actually is, watch this explanation right here. So we start with 225 kilograms, right? I'm going to show you another way that you could find the answer and prove that this is actually how much you have left. We start with 225, right? The half-life is, how long was the half-life? What does the problem say? 20 years. The half-life is 20 years. And how long are we going for? 100 years. Okay, so first, the first 20 years right here, 20 years, I have half of 225 left. What's half of 225? Use your calculator.
Oh, 220. I thought you said 20.
No. 112.5, right. That's after 20 years. That's one half-life, right? Okay, but that's not 100 years yet. That's only 20 years. Did I say 100? Anyways, so we have to go another half-life, 20 more years. So that's half of 112.5. What's half of 112.5? 56.25, right. But that's only 40 years, so I have to keep going. So let's go another half-life, 20 more years. What's left now?
20, 21.
Right, we half the 56.25, we get 28.125. Still not at 100 years, so we're going to go 20 more years. So we take half of 28. What is that? Okay, that's 80 years, so one more half-life will be 100 years, right? So let's take a half of 14.0625. What's that? 7.03 about, right? Which is just what you showed right there with the formula. So you see, that's what half-life actually is. You're cutting the amount in half every half-life. And then you can use the formula, though, to instantly find the answer. So that's the concept of half-life. All right, so now let's do one more example. A substance has a half-life of 100 years. If there are 150 grams of the substance now, how much will remain after 12 years? So here we go. A equals A sub 0 times 1/2 or raised to the t over h. So what is my starting amount here? 150 times 1/2 raised to the, what is the time?
100.
Read the question.
12.
After 12 years. Time is the time elapsed. Over the half-life. What half-life is? 100. It says that the half-life is 100 years. So there you go. That's the equation that you would use to find the answer. 150 times 1/2 raised to the 12 over 100. So what is that answer going to be? 138. Right, 138.03. And what are my units? No. That would be completely off. So make sure you do use the right units, okay? It is 138.03 grams. So that is the half-life formula. All right, our last problem is going to be back to the compound interest or continuous growth, but the way that this problem is a little different. This is kind of what we were doing yesterday. So notice that it says if $3,000 is invested at 4.5% annual interest, compounded continuously, key word right there, compounded continuously, we're using A equals P times E raised to the R times T.
Hey, Coach Goo.
Hey.
Bye.
Okay, so where am I? Okay. What is the starting amount here? 3,000, right? Okay, what is my, notice that down here it says how long will it take for the account to grow to 6,000? So what are we looking for here exactly? The time, that's right. We don't know the time, but we know everything else, or we should know everything else. What is the rate? 0.045, right, because it's 4.5%. There you go. And what is the time? We don't know, so we just put T. Yeah, you can put X or whatever. Right, and the final amount is 6,000 because they're asking how long it would take to grow to 6,000. Okay, so what are we looking for? We're looking for time. We actually have to solve for T here, and this is using the concepts we did yesterday. So how would I solve for T? What do you think I would do first? 3,000, and what do you mean exactly? We're going to divide 3,000 first, right? We want to get that 3,000 out of the way. Right. So what is 6,000 divided by 3,000? Not 2,000. 2. Equals E raised to the... Right, equals E raised to the 0.045 T. Okay, so now, remember, we're trying to solve for T. So what do you think I should cancel out next? E, I want to cancel out E, and how do we do that? ln, right, take ln on both sides. So we have ln of 2 equals, yeah, raised to the 0.045 times T. But what happens with the ln of E right there? Yeah, they cancel out. So we're left with 0.045 times T, and that is about, what is ln of 2 about? 0.69, right. So here we are. 0.69 is about 0.045 times T. So how do I find T then? Divide by?
0.045.
That's right. And what do you get? $15.33. But what would your final answer be here on this question? If you read the question, how would you write your final answer?
15 years.
15 years, right. Now, why did you say 15 years?
Because you can have 0.3 of a year.
You can have 0.3 of a year, right? Because that's just 4 months. But yeah, if you read the question, it says to the nearest year. The question will always tell you how to answer it, okay? So make sure you actually do read the question. All right, but that's going to end the notes, guys. So until next time, which would be, I guess, after the test or on the test review, I will see you in the next one. Peace!